Okay, on 66, what they gave you was tangent and cotangent. Well, we really don't need that for the formulas. We really need cosine and everything. But if you notice that, and let me write this one a little different. This one is negative 4 over 3. And we know that tangent is y over x. And we know that cotan is x over y for the beta angle. Since this alpha lives in quadrant 2, and this belongs to quadrant 3, we know that in quadrant 2, my sine is positive, and sine is y over r. My r is going to be 5. My r is 5 because this is 3, 4, 5. So this is going to be 4 over 5. And my cosine is going to be the negative, because cosine is negative in quadrant 2. So basically with this negative here, I can take it and it really belongs to the x portion. Alright, so this is going to be negative 3 over 5. Alright. Now for my beta, I have sine of beta. Sine is y, so that's 5. Now we know we're in quadrant 3 here. This is quadrant 3. So I know technically both of these are negative. Let me go back to orange there. So sine's going to be negative 5 over 13. Why 13? Because this is 5, 12, 13, and r would be 13 for this. Just knowing your triples saves you a lot of time. Cosine of beta, therefore, would be x, so that's going to be negative 12 over r. And once you have these, you're good to go. And we're going to do our sum and difference formulas first, the same way we did the prior two videos. So here we go. Make sure you write these down. Okay, so sine of alpha plus or minus beta equals sine of alpha cosine of beta plus or minus cosine of alpha sine of beta. And I'm going to look at my piece of paper, and sine of alpha is 4/5. Cosine of beta is negative 5 over 13. Let me make sure I did that right. Yes. Okay. Plus or minus cosine of alpha is negative 3 over 5. And sine of beta is negative 12 over 13. And if you notice that the denominators on the double angles will always be the same. So that makes it nice. You have negative 20 over 65 plus or minus two negatives here. That's going to be 48 over 65. And then we're just going to combine these. We need sine of alpha plus beta, and we need sine of alpha minus beta. So sine of alpha plus beta is going to be 28 over 65, and sine of alpha minus beta is going to be negative 68 over 65. You're going to want to write these down. I'm writing them down now. 28 over 65 for the plus, negative 68 over 65 for the minus. And we're going to want to do the same thing for cosine. This one's sine. Now for cosine, the formula for cosine is alpha plus or minus beta equals cosine of alpha, cosine of beta, minus plus sine of alpha, cosine of beta, and plug everything in. So cosine of alpha is negative 3/5. Cosine of beta is negative 5 over 13. Minus plus sine of alpha is 4/5. And cosine of beta is negative 5. Oops, this is supposed to be, did y'all catch this? Right here, this should be what? Sine. See, you already noticed that and I didn't. Alright, so now we have, did we do this right? Sine of alpha, 4/5. Sine of beta is going to be negative 12 over 13. So, as long as all these numbers look different, except for the denominator part, you're good. So that's 15 over 40, not 48, 65, minus, plus, negative, I'm going to do that, 48 over 65. We need cosine of alpha plus beta and cosine of alpha minus beta. So cosine of alpha plus beta is going to be 63 over 65, and when you subtract, you're going to 48 minus that is 33, so it's going to be negative 33 over 65. Now quickly write those down. So the plus 1 for cosine is 63 over 65, and the minus is negative 33 over 65. Now tangent, therefore, is going to be a piece of cake, because all we're going to do is divide those two numbers. Tan of alpha plus or minus beta, instead of using the complicated formula, we're just going to use sine of alpha plus or minus beta over cosine of alpha plus or minus beta. So for tan of alpha plus beta, I'm going to use sine of alpha plus beta over sine of alpha minus beta, and that's going to be 28 over 65 over 63 over 65. And the 65's cancel, so my answer is 28 over 63. Now, my tan of alpha minus beta, I'm going to do the same thing I did here, but with minus, and I already wrote the values down. That's going to be negative 68 over 65 over negative 33 over 65. These two cancel. These negatives turn positive, so that's 68 over 33. Okay? Now the next one we're going to do is the double angles. And the double angles, we're just only going to use the beta. So we're trying to seek a sine of 2 beta. And my formula is 2 sine of beta, cosine of beta. And we're going to use cosine of 2 beta, which equals, I'm going to use cosine squared of beta minus sine. If you like a different formula, go ahead and use that. This is the one I'm using because we already have our cosine squared and our sine squared, and that means I don't have to worry about finding a common denominator. And then my tangent of 2 beta, I'm just going to divide my results for sine of 2 beta over my results for cosine of 2 beta. So for this one here, sine of 2 beta, it's 2 times sine of beta. Sine of beta is negative 12 over 13 times cosine of beta is negative 5 over 13. So this looks like it's very similar to the others. This is 60, so it's going to be 120 over 169. And for cosine, I'm going to square this, which is negative 5 over 13 squared, minus square that, negative 12 over 13 squared, and you get 25 over 169 minus 144 over 169. That gives us negative 119 over 169. Now, when you divide these two here for tan of 2 beta, we're going to get 120 over negative 119. I'm just going to pull the negative and put it out here to make it look nice, and we are done. Because if you divide these two, the 169s would have canceled. Okay, now we also have to find our half angles. So we're going to find sine of theta over 2 first. And our theta happens to be, the book wants you to do alpha. So we're going to do the alpha angle. And we know that alpha lives in quadrant 2. So we need to know what alpha over 2 lives in. So I'm just dividing each piece by 2. And that would give us, sorry about that, pi over 4, alpha over 2 lives in between 45 degrees and 90 degrees, which is in quadrant 1. So alpha over 2 belongs to quadrant 1. And therefore I'm going to use the plus portion of my formula, 1 minus cosine of alpha over 2. And in this case, my cosine of alpha is negative 3/5. And I'm going to go ahead and write my 1 as 5 over 5 minus negative 3/5 over 2, which gives us 8 over 10. And I'm multiplying these two, which is the same as 4 over 5, which is the same as 2 over root 5, which is the same as 2 root 5 over 5 when you rationalize the denominator. Okay, now for cosine of beta over 2, I have to determine where my beta lives. Well, my original beta for this one lives in quadrant 3. So now I've got to determine where beta over 2 lives. So I divide each piece by 2. So beta over 2, the domain is 3 over here. This is 135 degrees. This is 90. So beta over 2 belongs to quadrant 2. Well, cosine is negative in quadrant 2. So our formula generally is plus or minus square root of 1 plus cosine of beta over 2. But since we're in quadrant 2 and cosine's negative, I'm going to change this to a negative. So the negative is going to be outside here. And then I just fill in the formula. 1 plus cosine of beta is negative 5 over 13 all over 2. So we get negative 1. I'm going to write this as 13 over 13 minus 5 over 13 over 2, which equals square root of 8 over 26, which equals the square root of 4 over 13, which equals 2 over root 13, which equals 2 root 13 over 13. Now what did I forget to do here? I forgot to carry my negative. So this negative goes here, 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 and here. So my answer is negative. For the last one, we've got to do tangent of beta over 2. That's going to be 1 minus cosine of beta over sine of beta. So I have 1 minus cosine of beta is negative 5 over 13. You can do that if you want. Over sine of beta, which is negative 12 over 13. That gives us 13 over 13 plus 5 over 13 all over negative 12 over 13. 13s are going to cancel. You get 18. I'll put that over 12. I can reduce this by each by 6, so that's going to be negative 3 over 2. And we're done.